Hello, good morning, everyone. Can you listen me?
Yes, sir. Good morning, sir.
Okay.
Good morning, sir. We'll be starting now.
Good morning. Yeah.
Okay. Thank you. My camera, my actually audio was creating problem. That's why I just left the meeting and now it's just again joined and it is fine. Thank you. Uh,
Thank you,
and
sir. Hello, everyone. Good morning. Respected authors and invited guests, welcome to the technical session 1D. Myself, Gayatri Bhurgada, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and TR Scholastic, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from 9th to 11th April 2026. I hope you all enjoyed the knowledgeable sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. Upon 9 minutes, I will raise a gentle reminder. And there is another request to all the participants that you all stay with us until the closing remarks. If you have any kind of query or doubts, you can write it to me in the chat box. And just before we start the session, I would like to introduce you all to the chair for this session. I would like to introduce you all to Dr. Mr. Osman Ali. He is a lecturer at the University of Education Lahore, Vihari campus, Pakistan. His research interests include artificial intelligence, machine learning, deep learning, data mining, computer vision, image processing, and cloud computing, with active involvement in teaching and research. So, would you like to address the participants?
yes, I can just give a short introduction of mine. Hello, everyone. Good morning to all. My name is Usman Ali. I am currently a PhD researcher in artificial intelligence, and I am honored to serve as your session chair alongside Dr. Bindia. I think there is a lot of interesting presentations today's session. Uh, like we can start from the because already we have time for the first presentation. Thank you very much.
Okay, sir, sure. Thank you, sir. Thank you for addressing the participants. I'd like to introduce you all to the second chair for this session. Dr. Bindya Jain is an associate professor in the Faculty of Computer Science and Engineering at Purnima University in Jaipur, India. Her research interests are generative AI, green AI, human-machine interaction, and IoT, and contributing to research and faculty development programs. She is recognized for her work in computer science. Now, I would like to start with the presentations. I would like to call upon Mr. Crystal James Tomey to present his paper titled A Hybrid Deep Learning Approach for Network Intrusion Detection System and Software-Defined Networking. Over to you, sir.
I think the participant hasn't joined. When this verified name.
Yes, we can move on to our second presenter then.
Yes, I think we can go for the second one.
I would like to call upon Mr. Emerson Joey Caro to present his paper titled Artificial Intelligence Enhanced Zero Trust Security Framework for Hybrid Cloud Enterprise Networks. You can start sharing your screen, sir.
Good morning, everyone. Let me just share my screen. Sorry, I was on mute. Good morning, everyone. Can you all see my screen?
Yes, you can carry on.
Okay. Okay. So, good morning, everyone. My name is Emerson Cara, and I will be presenting my study about AI-enhanced zero trust security framework for hybrid cloud enterprise networks. So the problem motivation for this study is to create a zero trust framework that spans on-prem, cloud, identities, endpoint, and SaaS solutions as well. Because the traditional perimeter-based trust is no longer sufficient. Security teams constantly need continuous verification, fast enforcement, lower false positives, and measurable outcomes. So the key challenge or for my study is to close the gap between those. And the key challenge is how do we connect telemetry to real-time policy-driven enforcement. Research question and contributions is how effective is an Azure native AI-enhanced zero trust framework compared with static controls in a hybrid enterprise environment. I've chosen to evaluate this study with 3 metrics such as time to detect, the decision latency, and the false positive rate. The main contributions for this are creating an Azure native reference architecture, an ML-based 0 to 100 trust score, and then it will bind it to a policy depending on the trust score via the automated score to policy binding, and quantitative A/B evaluation using the MITRE ATT&CK aligned scenarios, which we'll discuss on the succeeding slides. So for the framework overview, the framework is a closed loop security pipeline from ingest, detect, score, enforce, and measure. The components for the framework are broken down into 5 different categories, such as the identity enforcement, which utilizes Microsoft's Entra ID, conditional access, continuous access evaluation, and privileged identity management. For the telemetry and analytics, it is consolidated into the Azure Log Analytics workspace with the help of Microsoft Sentinel as the SIEM and source solution. It's also enabled via UEBA for user entity behavioral analysis as well. For the ML scoring, once the logs are ingested and an attack was detected, it will go ahead and call the machine learning model via Azure Machine Learning, and then it will output a trust score, which then, if the trust score is, for example, high, it will then enforce a high security measure or policy against it. The main idea is external ML risk scoring is translated into enforceable policy actions through identity group membership updates. So for the trust scoring method, feature examples used in scoring are failed attempts, out of hours, GeoJump for if the user, for example, accessed a session from another country and then and accesses another session in another country. The minutes since the previous session and then the privilege activation attempt, as well as it can also detect if the device is compliant or managed. For the model output, it calculates the risk probability and then it converts it into trust score. The interpretation is that the higher score, it's more trusted, and then the lower score, it's a stronger policy action. So for example, if this trust score is about 90, that means that it's somewhat safe. It's on a low criticality. For the experimental design, it's using an A/B evaluation. So the study is measured on 2 evaluation, which is called baseline and adaptive. The baseline only detects the attacks, the 3 scenarios, which are impossible travel sign-in, privilege activation attempts, and then the lateral move-in by SMB or RDP. So for the baseline, it just detects these 3 scenarios via Sentinel. And then for adaptive, it actually does the enforcement and the MS scoring. So the same detection logic is in both modes. The same dataset is used for both modes so that it has a fair comparison for both evaluations. And then the metrics are earlier, which are the time to detect, decision latency, and the false positive rate. For the aggregate results, baseline versus adaptive, the testing was 15 runs per mode. So these are across the three scenarios earlier. And the summary for this one is the adaptive mode reduced false positives, and then the median detection was slightly faster, but the decision latency increased. So why did the latency increase? The thing here is the ML model is not the bottleneck, but the main contributors are the trigger delay, automation sequencing, and enforcement path overhead, as the different scenarios often has some delays when it comes to triggering the automation, or it depends whether the scenario is run every 5 minutes or it's in near real time. So going back to this slide here, for the impossible travel, it is on a near real time rule. But the other two scenarios were run via 5 minutes interval. Because if it were near real time, it would cost massive runtime, massive run from Sentinel, and then it will overflow the SIEM source solution. And it's best to just batch them via a 5 minute interval. So the interpretation, what the framework achieves, it's a better filtering of safe or benign activity, better alignment between telemetry and enforcement, practical zero trust automation for hybrid environments. The trade-offs are a lower false positive rate and then a slightly better median time to detect, with a higher decision path latency. So the takeaway is that AI-enhanced zero trust is valuable, but peripheral efficiency matters as much as the model quality. For the conclusion, the proposed Azure Native AI Enhanced Zero Trust framework, it closed the loop from telemetry, ingesting the logs from different sources, such as the sign-in logs, the audit logs, the logs from the workloads, such as the virtual machines, as well as the logs from different past applications. If it detected that it has an anomaly or an attack, it would then trigger the SIEMs or automation. It will calculate the trust score, and then it will go ahead with the policy enforcement. It depends per scenario. For example, if it's an impossible sign-in, it will then go ahead and block the user, enforce MFA, or disable the user's account. It depends, because this is a framework. It is extensible, and it can utilize different actions. But the framework has inclusive from telemetry, trust score, and policy enforcement. So it demonstrated reduced false positives, comparable detection timing, measurable automation overhead. So for future work, I plan to have this on larger scale experiments, concurrency and load testing, calibration, PR-based model evaluation, and broader multi-cloud adaptation. So this is it for my presentation. Are there any questions for my study?
Just one question. Have you compared your this framework with any state of the art, or you have created a baseline and you have just compared it with your own baselines?
Sorry, sir, can you repeat?
I am saying that have you compared your framework with any state of the art existing frameworks, or you're just using a baseline by creating a baseline and then comparing your method with me?
So for the overall framework, this has been part of the study was also to bring in some of the frameworks such as the zero trust framework. Uh, but for the actual comparison, this is not compared with any other frameworks. The study is but the study itself, it was based on the zero trust framework.
Okay, thank you.
Thank you.
I would now like to call upon our next presenter, Indupriya Vempati, to present her paper titled Autonaut X, AI-powered multimodal node generation and interactive learning assistance. Ma'am, you can start presenting.
Okay, let me share the screen. So is my screen visible?
Yes, it's visible. You may start.
Good morning, everyone. I'm Indupriya and I'll be presenting our project titled Autonotex, AI-powered multimodal notes generation and interactive learning platform. And my teammates include Dr. R. Vasavi, K. Sai Anuradha, M. Pavani Tejasri, T. Navya, and Indupriya myself. So the agenda will be simple, the problem statement and our approach and the design we made, implementation and the results novelty references too. So coming to the problem statement, the students rely on multiple resources like PDFs, PPTs, audio lectures and video lectures, etc. for the preparation for examination. However, converting all this information into the structured notes, it's so much inefficient, time consuming and often leads to incomplete understanding. So there are some existing tools, but they are lacking visual representation and some self-assessment features also. So we felt the need of an intelligent automated system to simplify this overall process. And Autonotex is a multimodal AI system. It processes the input many documents like PDFs, PPTs, audio, video, etc. So overall, it uses a agentic AI using RAG. All the relevant content will be retrieved from the sources we have given, and then structured notes will be generated using the LLMs. The system enhances the learning by implementing the diagrams and flowcharts and building some interactive knowledge graphs and also enabling the concept level explanation. So it improves the overall efficiency and reduces the manual note taking effort. Sorry. And coming to the literature survey, there are some existing systems, but what they do is they mainly focus on speech to text conversion or text summarization. They do lack in some things like visualization, interactive learning features, multimodal integration. But what our approach improves this is like by combining RAG-based content generation, agent-based processing, and visualization techniques too. So this is the research gap we found. Like whatever the existing systems are having text summarization, there is no unified pipeline, and they do handle only one input. But in our platform, we are able to input any number of PDFs, PPTs, audio files, images, video, all at a time. And no existing tool is generating the subject specific notes. Like in our platform, we are just entering the subject name and we are getting the note from our database, which is MongoDB we have maintained. And here, there are no interactive knowledge graphs or AI powered concept explanations. And the existing models also lacking web enriched content. Web search is not integrated into their platforms, and they do lack user friendly interfaces too. So these are our objectives to develop a multi-model system which will be converting the heterogeneous sources into a exam oriented study notes. Also to build an interactive knowledge graph and to enable the subject specific notes generation to integrate the web search and also to provide the automated quizzes and the feedback to the user. These are the system requirements. So these involve multiple functional requirements in the null functional requirements. The system is highly scalable and extensible to different new models, and we can also integrate the new language feature if we want. Coming to the system architecture, the input layer will be uh, uploading any documents. It may be of different sources. PPTs, PDFs, etc. Also, we can enter the subject name if we don't have any learning resources. Then orchestration will be started. For handling different tasks, we are having different agents like graph agent, notes agent, diagram agent, question answer generation agent, and web search service, which is a microservice we integrated. And for backend, we have used a REST API and orchestration. So the DBs we have used is MongoDB for node storage and Pinecone for vector research, vector store. So for this, semantic search will be implemented, and in output we'll be getting the diagrams, knowledge graph, and structured notes. So this is the methodology we follow. And so compared our results with the existing platforms. So AutoNotex R1 is having good results in overall, like it may be the transcription quality, it may be the scalability and integration of multi-modeling, etc. So these are some implementation screenshots. So just by entering the subject name, we'll be able to get a structured notes, and we can integrate the web diagrams into the notes if we like anything. So these are the top questions with the difficulty levels also for that particular notes. And this is an interactive knowledge graph which we can traverse by just clicking on that notes, and we'll be getting the brief description about it. And here we can just enter the subject name and we can get the notes from the DB, and this is quizzes. So yeah. And the novelty we can say is like it's a true multi-model integration. It's not just a single source and getting single summary. It's a structured notes. Diagram integration. So diagrams we have integrated using three techniques. So we have just extracted the diagrams from the PDFs. If there are no diagrams available in the PDF, we can integrate the web search diagrams. And also we can generate the AI generated diagram using the Mermaid library, and knowledge graphs, which I have implemented using the RAG and web enriched learning, and as quick systems with the difficulty levels. End-to-end learning platform it is. So it's not just a summary, it's a perfect structured notes. So these are different references we have used, and thank you, and open to any questions.
Thank you very much. Yeah, it's very interesting study. I'm curious about the types of different agents you have shown. I just want to know how you handle communications or collaborations between different types of agents. Have you listed into a paper or explained this type of collaborations between different agents?
Yeah, we have different agent in this. Like for just handling the input, also we have kept one agent. We have used a LangChain framework, and so, for example, drag is there. This agent will be retrieving the content from uploaded documents, then
Yeah.
chunking and storing all those in the knowledge base, and then enabling the semantic search and summarization or generation agent we have. So this is for to generating the structured notes from the already available content. So summary length is like user defined. If user want only 100 words, it will give 100 word summary only. And diagram generation agent we handled. So this will be extracting the diagrams from the existing nodes, or getting from the web search, and knowledge graph, which I have shown like a node-based traversal. Quiz generation agent is different. So for handling all these, we have maintained an orchestration.py. So that,
Okay.
yeah,
Thank you.
thank you, sir.
Thank you, Priya. Nice presentation. But can you please explain what is the part of your work in your research?
Okay. So firstly, we have gone through different platforms which are existing, ma'am, like Notion, etc. are already existing. But
Please come
so
on
we have
your
worked.
first slide, title
Okay.
slide.
Yes, ma'am.
Yeah, please explain part of your work.
Yeah, I have mainly contributed in RAG, ma'am. Like, it is not a basic RAG, like, we have used a Pinecone vector DB. To get the relevant chunks, we have increased the efficiency using read anchor. So in normal drag, we'll be getting top 20 relevant sources from the vector DB pinecone. But what we have did is like we have implemented some other reranker.py using cross encoder and some existing models so that we'll be getting top 5 and efficient chunks so that it improves the content quality retrieval, ma'am. This is something unique we have did. And
Okay,
also,
thank you.
yeah, thank you.
Next,
We would now like to call upon our next presenter, Mr. Siddhalingappa Goda Biradar, to present his paper titled Circular Shaped Wearable Patch Antennas for 6G Application. So you can start presenting.
Morning, ma'am. Good morning, Usman Ali sir. So I'll be sharing my screen.
Good morning.
Okay, the paper title is Circular Shaped Wearable Patch Antenna for 6G Application. So this paper mainly tells about how we can create a wearable patch antenna for the 6G application. Myself, Siddhalingappa Goda Biradar. So the agenda here is to know what's introduction about 5G or 6G antenna, literature survey, methodology, simulation, and conclusion, future scope references. So if you see there, 6G, you know that with the evolution towards the 6G communication is shifting to terahertz from millimeter wave. This opens up a lot of critical applications in smart health and wireless body area network where wearable devices continuously monitoring the physiological data. So this is why we plan to use a 6G antenna, and this will enhance the smart healthcare, remote monitoring, and real-time data processing. So, body area network is a network of wearing or implantable sensors that can communicate wirelessly to monitor and transfer physical data. Wearable patch antennas are a small, lightweight, miniaturized antenna embedded into a wearable fabrics. Wearable antennas attached to the skin, as we know that there are smart watches which can attach to our body. So even these types of wearable devices can help us to monitor the physiological data of our body. So these antennas are lightweight, as I said, flexible antenna designed to function efficiently in proximity to the human bodies. So as we know that the upcoming 6G generation can be implemented through the smart shoes or smart belts, smart insoles, smart pants, smart rings. So a lot of wearable devices we can be designed or using this 6G antennas. So this will help us to know what actually the body responds. And the literature survey, if you see, I have compared my work with other papers, around 11 papers. So in most of the papers, I have seen that the generally in an antenna, we have a three layers. One is a patch, the second is the substrate, the third is the ground plane. So the substrate commonly used here is FR4 material, and we they use a graphene material, polyimide material, which are having a low dielectric constant. So here, as we are planned of designing patch antenna. So I have used a diamond and a gold as a substrate so that it looks attractive and works efficiently, because these two materials have got very low loss of dielectric constant. And I used a CST tool to design and simulate this antenna. So when I started designing of antenna, so I have gone through this site called as Pasternak, where if you want to design any antenna for particular frequency, if you give the dielectric constant and height, so it will give you the length and width of a patch antenna. So with the help of this length and width of the patch antenna, I have designed a circular patch antenna where you can see here there is a formula in order to design a patch antenna. So if you have a width and length that we got from that website, so if you substitute here, you'll get a radius of a patch. So with the help of that, we have designed with these parameters a circular patch antenna. So if you see the methodology, how actually it is going to work here is initially we set with a certain frequency, and this website will give a length and width, and we simulate that antenna, and we check the performance. If the performance is not satisfied, again we modify it, we change the design of an antenna, or we can add slots in a patch antenna which will bring a better results. So this is how the process is done, and this all things are done in using a CST tool. So here, if you see, this is a design. You can see figure 3, circular patch antenna. The behind this patch, you have a substrate. So here, diamond as well as gold is a substrate that I used. Behind that, there is a ground plane, which will be again a copper material. So these are the materials that are used, and the variable parameters. So as we are creating 6G wearable devices, we need to consider certain properties of human body tissues. So when once the design is completed, so we test with respect to the human properties of a body, so that the radiation effect should not be there on a human body. So to do that, we need to consider certain properties like conductivity, loss tangent, tissue permittivity, like skin, fat, muscles. So these are the properties that will be inbuilt present in a CST tool. So using this property, we will be testing this antenna so that whether this antenna has less loss, or if there is any issue in the result. So that will be checked, right? Analyzed. So if you see the simulation result, here once I used a diamond material for this circular patch antenna as a substrate, and the other I used a gold material. So if you simulate here, if you see here, this parameter, reflection coefficient, we oftenly call it as a return loss or a scattering parameter. So it's below minus 20 here, if you see. There are other dip here. You can see one at, if you see the blue color diamond material, it has dipped at minus 20.32, and at 4 terahertz frequency, that is of minus 27.54. Right. So this tells that the antenna is working perfectly at this frequency, means the return loss of the antenna, which is with a diamond material, has very less loss. So similarly, for a gold material, there is a dip at 2.56, where we have a return loss of minus 22.12 dB, and 46.63, 4.63 terahertz, we have minus 13.63. So again, we have a two dip at a gold material. This tells that the antenna works with a dual band. Means if you are using a diamond material, you can operate at 2.20 as well as 4 terahertz. If you are using a gold material, it can operate at 2.56, 4.63 terahertz of in a resonating frequency. Similarly, we have a one more VSWR parameter that will tell that how much amount of power is transmitted. So if the value is close to 1, it indicates that there is a successful transmission of power, means loss is very less. If you see the resonating frequency which we have at 2.204, 2.56, 4.63, so the VSWR value is 1.67, 1.10, 1.12, 1.54. So among all these frequencies, we have considered two frequency, best frequency where the antenna works, that is at 4 terahertz and 2.56 terahertz. And if you see this is one more parameter where we call it as a far field for gold material, far field for diamond material. So this parameter tells that how the beam radiation is happening, whether it is circular or specific to the particular direction. So as we are going towards 6G, so most of the antenna that's are designed are MIMO antenna or specific to particular direction. So this antenna shows that here you can see there is a main lobe and there is a back lobe. So these are the two beams that we are able to see when we are using a gold material. Means it's direct towards a particular area, so the gain as well as efficiency of this radiation antenna is very good. And if you see in a diamond material, even there is a good radiation effect on either side, front as well as a back. So this will tell us that there is a good directivity, and beam width is very high, that is 96 degree to 60 degree. Gain is also good, which tells that it is focused to particular direction. Efficiency is better, that is 75% to 87% high. So from all these parameters, we can understand that the design which I have done or our team has done is providing a strong radiation pattern, and it has a spherical shape. It's a directional antenna because it's focusing on a particular direction, better focusing, wide band, right? This will help to cover many areas. Dual band antenna has been seen that the antenna operates with two frequency, and this will be best suitable for 6G wearable systems. So it's not an easy.
Excuse me, sir. You have
Uh,
1 more minute left to present.
Okay, ma'am. So last slide. So if you see overall the gold and as well as diamond, so it and we have tested this with, as I said, with a specific absorption rate (SAR). So to know that how this antenna work when it is put on a skin, fat, muscles, so it works very well. It has very low loss, that is 0.014 and 0.001 kilowatt. So, if you see overall, in a conclusion, for the antenna which is there, it works better if you are using a diamond material at 4 terahertz and gold material at a 2.56 terahertz. Thank you, sir. So these are the references.
Uh, Thank you, Dr. Brother.
Okay,
Well, just
you are
Yeah,
telling about 6G application with patch antenna.
yes, ma'am.
Okay, uh, which type of 6G applications you are prefer for future perspective?
Ma'am, generally, whenever we have a wearable systems, we need to have antennas. So, without antennas, we can't interface that system to the mobile or any laptop. So that we need antennas. So these antennas which are there, whatever the designed antennas, circular patch antenna, this can be used for wearable devices. For like a best example is a smartphone, or we can have a pendant, a gold pendant, diamond pendant. So for that you can use this as a antenna, and it can keep on monitoring our body health, and we can interface this to a mobile or any software, so that we can check the condition of our health. So as
And
oftenly we use a wearable devices like chains. So this can be a part of that, and it looks better to.
and because of radiation, uh, the effect of radiation in body.
Ma'am, that we are checked during the simulation. The whatever the electromagnetic signal that is produced by this 6G antenna is not affecting much. So it's a safety to use that. That we have checked by doing the simulation with respect to, you can see here, ma'am. So we have checked with the skin area, fat area, muscle area, and it shows that better result. The loss is very less.
But it affect the body, no? Not too
Uh,
much, but it little bit.
uh,
Am I
uh,
right?
Ma'am, because as we know that we are using a smart watches,
Mm.
so we see
But
a
this type
rare
of
effect.
criteria you have to remove. you have to work more on this part, no?
If you fabricate
Okay,
this
fine.
antenna and test, it will be known better.
It is my recommendation to you. Okay.
Okay,
Thank you.
ma'am.
Next,
Okay, ma'am.
please.
I would now like to call upon our next presenter, Mr. Ioannis Petias, to present his paper titled Extending Latency Models for Long Sequence Inference, Nonlinear Adaptive and Empirical Enhancements. So you can start presenting. Hello, sir. Are you present?
Yes, can you hear me?
Okay. Yes, yes, you're audible.
Okay. Okay, just a minute. And you can see my presentation now. Well, hello
Yes, your screen is
everybody.
visible.
Hello everybody. I'm Ioannis Patias and I will present you our work we developed with Professor Koutaro Hachiya, extending latency models for long sequence inference as discussing non-linear adaptive and empirical enhancements. But first of all, why latency modeling matters? As LLMs are now used everywhere, these models grow and their influence increasingly depends on how efficiently they can run in real-world systems. One of the most important metrics here is inference latency, especially for applications like real-time translation, autonomous driving, or interactive AI tools. Starting with a common latency model, latency can be expressed as a function of model size, compute resources, quantization, sequence length, and hardware. This abstraction is useful, but it breaks down when we move beyond short sequences. Empirically, latency does not scale linearly with sequence length. In transformer architectures, attention mechanisms scale quadratically, and this becomes a major bottleneck in tasks like long form of Q&As or document summarization. As a result, linear models systematically underestimate latency, which leads to pure scheduling decisions and degraded user experience. So the core reason for non-linear latency is the attention mechanism. Every token interacts with every other token, so as the sequence grows, the number of interactions grows quadratically. But algorithmic complexity is not the only part of the problem. Longer sequences also stress the hardware. They exceed cache capacity, triggering more memory transfers and so on. And these effects are not proportional. They escalate once certain thresholds are crossed. So the scope of our work. The scope is to make the behavior more transparent. We categorize sequence lengths into form regimes, short, mid, long, and extended. Each regime corresponds to different tasks like language modeling, retrieval, augmented reasoning, and so on. And this categorization helps us understand how latency behaves across different ranges. The proposed enhancements. The proposed enhancements are modifications focused especially on transformer-based architecture. We do not attempt to model non-transformer or hybrid systems and reduce attention complexity. Also, our paper is conceptual. We focus on the formulation and design of improved latency model. Empirical validation across hardware platforms is planned in our future work. So to address the limitations of existing models, we introduce three enhancements. First, a non-linear term that captures the superlinear growth in latency due to attention and memory overhead, a sequence length dependent scaling factor that adapts to different models and hardware configurations, and the third is an empirical correction term that fine-tunes predictions in edge cases or under presented settings. Together, these modifications produce a more expressive and accurate latency model that aligns better with real-world behavior. In summary, we identify a key limitation in existing latency models. We propose three enhancements that addresses this issue and improve prediction accuracy. And finally, we discuss the practical implications for deployment, scheduling, and system design, especially as LLM continue to scale. As background, latency is central performance metric for real-time AI systems. A simplified version of these relationships is shown here. The linear formulation works reasonably, as we said, well for small input, but it becomes inaccurate as we move to modern transformation large language models. Linear models assume that latency grows proportionally with sequence length. That assumption collapses once we consider transformer architecture. That's the main focus. So recent work has explored many ways to reduce latency, inference latency, using quantization, caching, and other optimization. These techniques help speed up LLMs, but they do not solve the modeling problem. Benchmarking studies repeatedly show that sequence length is a dominant factor in latency behavior. However, very few predictive models explicitly incorporate nonlinear or adaptive terms for sequence length. Most rely on empirical profiling or hardware-specific heuristics, which limits then generalizability. The first enhancement. Our work directly addresses the limitations of linear latency models. So we introduce the three enhancements, first of which is that unlike the previous formulation, they treat sequence length as static linear factor. The first enhancement introduces the non-linear term for sequence length transformers that quadratic time and memory complexity because every token attempts to every other token. This makes latency growth much faster than linearly as sequence length increases. Gamma here reflects the effective growth rate of latency and can be calibrated per architecture or hardware platform. The second enhancement introduces a dynamic scaling factor for sequence length. The impact of sequence length is not uniform. For instance, a 512 token input may be trivial on a high-end GPU, but problematic on an edge device. This is why we link edge architectures with latency calculation. Even with nonlinear and adaptive terms, theoretical models cannot fully capture hardware-specific behavior. Different GPUs, TPUs, and software stacks introduce variation due to kernel optimization, memory hierarchies, and parallelization strategies. The result is a model that adapts to real-world behavior and remains accurate across diverse hardware and workload. In the discussion, we combine these three enhancements directly and address the shortcomings to linear latency models. Together, they produce a latency model that is significantly more accurate, interpretable, and generalizable across tasks, input lengths, and hardware platforms. But why do we need multiple enhancements rather than a single fix? Linear models are simple and interpretable, but they break down in long sequence tasks. Each enhancement we introduce addresses a different limitation, like theoretical complexity, context sensitivity, or hardware-specific behavior. So we compare the enhancements across several dimensions and outline each one where is most effective. In the table, we summarize the three enhancements. These trade-offs that we present help determine which enhancement is best suited for a given deployment scenario. As
Sir, you have
deployment
one more
recommendation.
minute left to present.
Yes, I'm on it. As deployment recommendations, we provide more details for each of the proposed enhancement in the presented work. Our future works. Our future works in research and development, the nonlinearity term provides a principal estimate without requiring deployment data. Before deployment, the scaling function helps. In production, the empirical correction term fine-tunes predictions. So, finally, uh, there are several promising directions for future work. Dynamic profiling, performance learning, hardware-aware modeling, and task-specific calibration. These directions point out toward a more adaptive and intelligent latency modeling framework. And to conclude, this work addresses a key limitation in existing latency models, their inability to generalize to long-term sequences. We introduced three enhancements, and each enhancement focus on a different aspect of latency modeling challenge, and together they form a modular, more accurate, and deployment-ready framework. Thank you very much for your attention. I will be glad to discuss any further questions.
Sir, interesting. I just want to know, have you included some architecture or flow of your work in your study? Because I think it's missing in the presentation. And also one more important part, the citation and references. You cannot see these two. These are just requirements of general presentation or your article.
My feedback is not that good, so I will repeat the question to make sure that I understood. Your question is whether we have introduced just a theoretical model or we have some practical examples. That's the idea.
Yeah, framework or some flowchart type
Yes. Okay, I
architecture.
understood. So until now, our work with Professor Hachiya was first to introduce what we call a trivial model with linear representation of latency based on the mentioned parameters. So what we got as a result conducted is that, yes, this formulation, this formula, this way to calculate latency is accurate when the sequence length is small. What do we mean small? Small, we need comparatively small depending on the used architecture. Now we want to extend this research, to extend these calculations, and try to produce a generalizable, this is the key point, model that could be applied no matter the length of the sequence, no matter the platform used, the hardware platforms used, or even more, no matter the quantization or other techniques, parallelization and so on, techniques used for the purpose. So this is what we are trying to propose now. A model that can be used for more
Sorry to interrupt, sir. I just wanted to know about a framework or architecture. Have you included in your article, or these citation and references are missing in your presentation? This is the simple question you have explained about. Thank you.
Okay.
Thank you for your presentation. Now I'd like to call upon the next presenter, Mr. Joao Paulo Sousa, to present his paper titled Immersive Virtual Reality for Awareness and Development of Emotional Self-Regulation Skills, the Case of the Dear Alfred Project. So you may start presenting. Okay, I think sir isn't present right now. We can move on to the next presenter. I would like to call upon Ms. Sushmita Sarkar to present her paper titled Multi-Secret Sharing Scheme with CSS Codes. Ma'am, are you present?
Yes, am I audible?
Yes, ma'am, you're audible. You can start presenting.
Thank you. Is my screen is visible?
Yes, it's visible.
So first of all, thank you the organizing committee of ICTIS 2026 for providing me the opportunity to present my this work, and good morning to everyone. So today I will discuss the work entitled Multi-Secret Sharing Scheme with CSS Code, and and here is the overview of my today's presentation. And first of all, I want to introduce what is secret sharing scheme using an application. And then I would like to introduce some preliminaries that is used to design our protocol. Next is our construction and the efficiency analysis. And then I want to conclude this and some of references. Next, so here we can see that suppose there is some company and some executors of the company are there, and signature will be valid only when or some T of the executors approve these things, and this can be done with secret sharing scheme. Next is some cryptographic preliminaries. We can see that secret sharing scheme is defined by a method where a secret S can be divided into the multiple pieces that are called actual shares and distributed the shares among the participants such that the authorized subset of the participants can reconstruct the secret, while the unauthorized subsets of the participants do not learn anything about the secret. So next is multi-secret sharing scheme. That is actually a secret sharing scheme where the secret contains multiple bits, and the sharing phase and reconstruction phase same as the secret sharing scheme. Next is sliding my share. Next is the minimal access structure. Here, minimal access structure means the authorized sets which contains minimum number of the parties, and that is denoted by gamma min. And minimal code word is a code word whose leftmost component is 1, and the support of C, that means the positions where Cj is not equal to 0, that support contain only the scalar multiples of C. Next is the characterization of authorized states, like which of the parties are authorized and which set of the parties are unauthorized. That was given by Gottsman et al. And here is a lemma represented by them, and where the equation 1 represent the condition when we say the set is the authorized set, and equation 2 represents that the set is the unauthorized set, where E is an error operator, and a basis of an error operator on a Hilbert space can be generalized or can be characterized with the basis error operators, and a basis error operator for a single qubit system can be represented by Pauli X operator and Pauli Z operator by equation number 3. And for an n-qubit Hilbert space, it is simply the tensor product of the error operators. Next is the main building block of our paper, that is CSS code proposed by Bank, Shore and Stein. And here it is a quantum error correcting code that is introduced using two linear ports, say C1 and C2, and its dual port C2 bar, and the encoding of the error correcting is represented by equation number 4. In our paper, we have assumed NKD CSS code from a classical NK1D error correcting code, where k equal to is 2k1 minus n, that is greater than 1, and it can correct errors in the field if nq minus c direction c or c perpendicular direction c perpendicular. Next is our proposed scheme, where it is a multi-sector sharing scheme, and we have a lemma that ensured that if a code word belongs to C minus C perpendicular, there is another code word such that x dot y is not equals to 0. For the time being, I am not going through the code. However, we are proving this theorem using contradiction. And here is the main construction, where let S equals to the secret S1 is to Sn, that is an n-lead secret. And we have encoded the secret by equation number 5, and this is a n qubit system. And if there is an n number of participants, each qubit is transmitted to each participants. Where GI is code words, where G1, G2, Gk are linearly independent subset, and S is the secret, and X belongs to the dual of the code word. And next, this theorem follows the minimal access structure, gamma minimum, represented by equation number 6, and the reconstruction of the secret is represented by equation number 7, where SL is the share sent to the Lth party, and A is the matrix, coefficient matrix of the linearly independent code words, K linearly independent code words. Next, this is our proof. And again, I am not going to the details of the proof. We just only adding k ancilla qubits and multiply these qubits with A inverse Cj, and calculating the proof, we have seen that at last we have this term G1, G2, Gk transpose S1, G1 plus dot dot Sk Gk, and the secret. So here we have seen that this term is a non-zero vector that is ensured by, and their product will be non-zero, that is ensured by lemma number 1. And this is non-zero because this is linearly independent set. So at least element will be not equal to 0 here. And next, we have completed the structure, like there is no other authorized set, and the authorized set is Milliman, that we have also proved. And for efficiency analysis, we have seen that our protocol is linear in terms of the participants. So there is some drawbacks and some significance. So that here is the conclusion. Like, we have constructed a multi-secret sharing scheme and its access structure, but as its efficiency linearly to the number of the participants. So when the number of the participants increases, its implementation may require further optimization. And as a future work, we have determined to design to simulate this in Qiskit Python environment and design the corresponding circuit of it. And another interesting future work is the designing of multi-sector sharing scheme in another realistic noise model like quantum fault tolerant system. So these are the references where actually we have a paper introduced by Sharvapalli and Klapenikar, who designed a secret sharing scheme of 1-bit secret using CSS code. Actually, we have generalized the concept, and there is another paper in the reference number 7 by Gupta et al., who has designed a multi-secret sharing scheme using face error correcting code. 3-qubit phase error inputs. So from these two papers, we have got the idea, and these are the these are the result. Thank you. If anyone have any questions, please can ask.
Yes, one question. Which is Python version you have used?
Actually, I am doing in Google Colab. That is, I think, 12. Python. Actually, I'm forgetting now. But the online Python Google Colab where we are simulating. We are working on it till now. It is in progress.
Yeah, just a suggestion. Just
Yes.
try to enlist whenever you use this type of system. We try to enlist the system requirements and the versions of the language or tools that you are using. Colab is just cloud version, cloud Python, like you can say the results generating tool or Python scripts learning tool. I am asking about Qiskit Python version you use in your current work. Thank you very much.
Thank you.
Any question? Hello?
Thank you for your presentation. Now I'd like to move on to our next presenter, Mr. Carl Kubleno, to present the paper titled Persistence Authority in Agent Systems, Memory Poisoning, Provenance Laundering, and Remediation Complete Containment. Over to you, sir. Please start presenting.
Thank you. I'm sharing my screen now. Hope you can see my screen. Good. Hello,
Yes, your
everyone.
screen is visible.
Yes, I'm Carl Kubleno from Aalto University. Today, I'll be talking about a problem that we've identified in AI agents that use persistent memory. As more AI agent deployments are being deployed, and there needs to be the security element. And the main objective of this study was to actually investigate the existing agent frameworks that were being deployed and their memory primitives to see if they were still vulnerable to certain memory-based attacks that were in the literature and how they could be mitigated. So the agenda would be to detail the problem and then introduce the system and threat model and then give definitions of the core concepts that we are proposing and then the framework characterization as well as experiments and some key takeaways. So at the core of the problem is durable memory. So since the advent of LLMs and then agents, memory is just seen as like one element, but the instructions, which is natural language, can now be interpreted by these agents as actions. So now we need to have a closer look on how the memory is formulated and the layers of hierarchy within the memory. So now from typically when you notice a vulnerability in a system, what a standard incident response does is you patch the code or you identify the location and then you rotate credentials and then you restart the process and then you have mitigated that vulnerability. But with durable memory, instructions can then go into the memory and even after you patch and rotate and restart the process, the instructions still remain, and during any retrieval, any RAG process, or any agent's workflow, the vulnerable memory instructions can still be read as with the same authority as the main task that is being run to then be able to compromise these agent systems. So it's a pressing issue that needs to actually be looked at with specific detail and investigated. So I would first then introduce the threat model and introduce some specific variables before we go to the architecture. So our system model is minimal. The agent has the human principal tools, a durable memory store, a retriever, and then a planner. So the core proposal that we have is memory partition. Right now, we just see memory as, especially as how the agent frameworks provide the memory as like a primitive that to just store and retrieve. But we believe that there needs to be a partitioned element so that we could have a hierarchy. So we define these origin classes as U memory, user authored with higher trust, then A memory, which is the agent generated inferences at medium trust, and then X memory, which is external content, because these agents can search online, and if there are vulnerable or specific threats, the instructions, they could just be retrieved. So we are trying to derank or like put this at a hierarchy. So this is highly untrusted and should never be treated as instruction, so that the adversary only needs to get content into the memory store once through to get content so that they don't need to have more of like an ongoing access. That is the main objective. So looking at the pipeline or the architecture, you can see the standard incident response on the left, where you have an external source that can have write access to your agentic system, because you are searching online for like doing research with agents. They go and search a vulnerable website and then take those instructions in to further continue. So this has been clearly represented in the literature, but then they don't go the next step on like to give like a detailed threat model and then a new way to actually do incident response. What happens when there are fake instructions in my memory? This is the question that we hope to solve, and we introduce the concepts of provenance and namespace and then gates, which we'll detail later with the definitions. So the standard process and then the new components that will intercept at write, storage, and consumption. So to quickly define provenance laundering, which is like the X memory is laundered if at inference time the planner treats it as equivalent. So we call this mechanism provenance laundering. It's when external origin content gets stored in memory and is later consumed by the planner that we introduced earlier. So this can manifest in two ways: the gradual bias, where the agent slowly shifts its preferences, which could be like a long-term attack, or explicit directives that trigger clear policy violations that you need to now respond to. Either way, containing it is the challenge is the same. How do you actively just remove natural language? That is now an attack vector. So based on how we partition the memory, we realized that we formalized this theorem that without memory purge, the expected impact of a compromise does not converge to zero. So because it can either be short-term or long-term, it grows with continual operation. But with purge, the impact is bounded to the compromise window. So at what time did you make those search like tool calls with the agent, those search to introduce the vulnerable instructions? So once you have that time window, you can then actively purge all memory within that time window in the partition. So credential rotation, it just changes tokens and the restart reloads the process, but the memory still remains. So this targeted purge is what we think is one way that we can mitigate this. So we did a literature analysis of the existing frameworks and how they are all introducing these memory primitives, but more of like as a high level memory primitive, and it's not being partitioned. It's just store and retrieve, which is good for the developer, but then it puts the security elements now on the developer, and so by introducing these partition context concepts and then the provenance, we believe that it can strongly. So this was more of a Q1 2026. This was the current state from our literature study and as well as within the research done by previous researchers. So as I highlighted with the partitioning, so now to actually contain the vulnerable instructions, we have provenance metadata that where every item would carry this metadata in the partitioned memory, the namespace separation, and then a gate so that you like the memory partition with the lowest trust cannot escalate in that sense. So now, with some of the experiments that we run using the existing frameworks, you can just think of it as if you are vulnerable, you are immediately attacked. If you are not vulnerable, like using our mitigation, the attack was unable to succeed. So with the baseline where there was no memory poisoning, it was immediately the attack went through. But once there was an inject and a patch and the rotator restart, that does not stop the attack. But the specific approach now would be the behavior only stopped after we purge the memory. So that purge primitives with the partition memory becomes very useful here. So with the previous slides where I introduced the metadata and then the containment gates, you can then see that this is more of a clear ablation. When we remove a single component, the unauthorized action executes every time. But when we have all three containments, we are able to mitigate all those attacks. So this is more proof that we actively need these memory partitioning and then the metadata on top of the current agent memory tools that are being provided by these frameworks. So now to wrap up, persistent memory, it creates a remediation gap that standard incident response does not cover. So the containment primitives that we mainly introduce are the provenance metadata, the namespace separation, and then inference time gates. So as of today, the current frameworks, they do not, they put it now on the developer and the operators. So we propose these primitives to actively help to mitigate some of these agents' security challenges that we will be facing soon. Thank you. And then some references of existing literature that's helped inform the research direction. Thank you.
Dear Carl, just want to know about your proposed technique is working on the top of existing frameworks. Which existing
Yes.
frameworks like LangGraph or Llama?
Yes.
Which existing framework specifically can
So
be
it's working
used?
on, we tested this against LangGraph and then OpenAI Agent SDK.
Okay.
Yes, so they all provide like memory primitives, and then we actively tested it against so that we would have this memory hierarchy and a trust level for each, and then so based
Just
on our test.
curious about your ablations because
Mhm.
in ablations there are no like framework specific insights. Which
Yes.
framework your technique is using here?
Yes. So here specifically, like I use those two specific frameworks.
You can just
Yeah.
name
So
the evolutions because it can be clear for the reader.
all right. Okay. So the idea here was when we remove a single component. So I highlighted a component here, the provenance metadata, which was every item carries origin class. Then the namespace separation, the hierarchy, and then the gates, where the lowest memory level, which is least trusted. So now when we remove a single component, the unauthorized action executes every time, which was we intentionally poisoned the memory, and then we had these gates. So when we remove one provenance metadata, the agent framework follow the instructions of the poisoned memory. But when we, with all three gates, we were able to like block the unauthorized action.
Okay.
Yeah, that was it.
Thank you for your presentation. Now I'd like to call upon our next presenter, Nitika Gavande ma'am, to present her paper titled Profanity Analysis in Hollywood Movies. Ma'am, can you please start presenting?
Is my screen visible? Hello?
Yes, it's visible now. You can start.
Okay. So I'm here to present a paper profanity analysis of Hollywood movies. Movies are a huge part of our culture. They are what people watch. They also have a certain effect on audience. As we have a huge, as they have a huge audience, moving through different eras of movies also transcends us through shift in culture and languages. As we might have observed in the back of our minds that there has been a certain shift in everyday dialogues. We try to analyze that shift, specifically focusing on the usage of profanity over the years.
Ma'am, can you please close the Zoom tab, which is on the bottom right corner of your screen?
Yeah,
Yeah.
sorry about that. So our problem statement is to analyze Hollywood movies. We have studied over 285 plus movies from 90s to 2025. We have focused on year and also did genre-wise analysis, focusing on frequency and severity. Existing work has been mainly focused on social media moderation and limited NLP usage. Here is where we try to gap the research. Current research, we there has not been over 30 years of movie analysis. There's a lack of genre-wise comparative analysis, and there has not been analysis of more masked words and more NLP usage. This is where we try to cover the gap. The data sets that we created have over 285 plus Hollywood movies, as mentioned earlier, and it's a balanced, homogeneous data set. 3 movies per genre per year. Main focuses are on action, comedy, and romance genre, but we've also included horror, sci-fi, and drama. Um, uh, Datasets metadata includes year, genre, and subtitle files. Our next datasets contains over 1,500 profane words or curse words. These might include spelling variations, the way they're written, and other kind of variations and spelling patterns, and they are categorized by their severity. The tools that we've used is Python and Flask for the backend, Pandas for data processing, and SRT files. And we've visualized all of that in front end using React. The environments that we've used is VS Code and GitHub. Now I'll briefly explain the methodology and NLP techniques used in our process. We started by building a structured pipeline that processes both dataset level information and raw subtitle files in SRT format. First, we load a predefined dictionary of curse words from a CSV file, which includes severity ratings. These ratings are normalized into three categories: mild, strong, and severe. Next comes the core NLP pre processing. We clean and normalize text by converting it into a lowercase, removing special character, and handling obfuscated words like F at the rate, hashtag, etc., using character replacement rules. We also reduce exaggerated spelling such as shiiit into a standard format using a regex based normalization. This ensures better matching accuracy. For tokenization, we split text into words using a regular expression, allowing us to capture both normal and styled profanity. Each token is taken compared against our normalized curse word dictionary. Additionally, we use pattern based regex detection to catch stretched or repeated abusive words that may bypass the standard matching. In subtitle analysis, we parse SRT files into timestamp dialog blocks. This allows us to not only detect curse words but also track when they occur in the movies. We aggregate results to compute frequency, severity distribution, and trends across years and genre. Finally, we expose all the results through Flask API, enabling visualization of trends such as curse word usage over time, genre wise comparison, and severity analysis. Results, we've observed that there has been a significant visible increase in profanity between the year 2004 to 2014. Action genre has seen the highest curse word usage compared to any other genre. Comedy genre has seen increase in profanity usage in recent years. It sometimes is always also comparable to action genre nowadays. Drama genre, horror, and sci-fi has seen relatively low curse word usage. Additionally, most of the curse words used are in the mild category. These are system outputs. Here you can see from 2004 to 2014 there has been a certain increase in curse word usage. Here we have compared three genre. As we can see here, action and comedy are competing for the highest curse word usage. Action words have highest number of profanity usage, reaching to 2000 words per movies. And here romance, which also has relatively high curse word usage. Conclusion, profanity usage has shifted over time. There has been strong variations across genre. So horror genre has literally no curse word usage, but compared to action movies they have high curse word usage. In future scope, we can also expand this to more genres, use a more number of movies, and apply advanced NLP techniques. Thank you.
Thank you, Nitika. Just want to know how you handle regular expressions in your current work.
Sorry.
How you handled regular expressions in your system?
Regular expression. Okay. We used regex multiple stages of our pipeline to make a profanity detection more robust and flexible. We used patterns such as at the rate dollar sign hashtag. This allows us to capture both normal words and words like sh star t. This ensures we don't miss stylized profanity. We removed unwanted characters like we stand normalized if there's a word that's exaggerated like fuuck, so we converted it into fuuck and did it until it matches like a format.
Oh,
We also used examples in our training data set.
okay.
Thank you.
Yes, next, please.
Thank you for your presentation. I would now like to call upon the next presenter, Mr. Kostiantin Rishenko, to present his paper titled Structure State Representation for Action Mass Reinforcement Learning and Flexible Job Shop Scheduling. Sir, please start presenting.
Good morning, everyone. And this work was done together with Professor Alexey Pasarchuk at Kiev Polytechnic Institute. And I will show how careful construction of observation space and reinforcement learning could improve skill quality. Let's briefly remind the problem setup. We have a set of jobs. Job consists of the sequence of operations, and those operations should be scheduled accordingly as the relations defined by this sequence. Each operation could be scheduled on different machines available for this operation, and the execution time of this operation also depends on which machine we choose. So that's a classical problem, also known as one of the NP-complete problems. So there are four main families of algorithms already existed for this kind of problems. The first family is exact optimization. It's mixed integer linear programming, constraint programming, branching bound. So the good side of this method is that can guarantee the optimality, so it works good on the small instances, on the simple instances, but it easily can be like overwhelmed, and the solution time could be increased on large instances to hours or even days. Next one is dispatching rules, heuristics. That's a fast algorithms, easy to deploy, easy to create, but it on the most time it could give us like low quality solutions. Also, it's hard to generalize them. So upon time, they could just give the lower quality with the data change. Also, there are a lot of meta heuristics like genetic algorithms, particle swarm optimization, and so on. They are like really strong on the benchmarks, but on the runtime, on the production, it requires a lot of time to tune the parameters, and they should be like refined over time with the data change during the production operation. Yeah, and the first one is new one. It's learning-based methods. Also, they called neural combinatorial optimization. It use neural networks to solve optimization tasks. In this work, we used proximal policy optimization algorithm with structured multi-layer percentron encoder with some semantics added to get better quality solutions. So the overall scheme is we have a job shop environment which encapsulate current production state, current particle schedule. It could accept action which define operation machine pair. So it said where we should schedule this operation. Also, it returns reward and action mask. Also, it implement like transition from the one state to another. The reward in this approach, we implemented the negative difference between previous end of the last operation and current end of the last operation after new operation scheduled. So why it is hard to implement reinforcement learning in job shop? So there are a lot of operations and that leads to large action space, and there are heterogeneous observation space. It includes also machine availability, feasibility of operations, which operations could be scheduled on this step. Also assignment impact, so that's earliest possible operation start plus duration. So it's like predicted finish of the operation. And the problem is this all mix up in one layer, in one flattering representation, could lead us to flattering of the signal and the worst learning we could get from that. So we proposed a structure with the three different branches of multi-layer perceptron for each semantic block. The first block is a resource block. It represents machine availability and current time of the latest operation. Next block is readiness block. It represents which operations currently feasible to allocate. It's like Boolean tensor. And the third block is earliest feasible start for each operation and their processing durations. Yes. Previously, as a baseline, all the observations was flattened and go like a single vector to multi-layer perceptron. With the proposed approach, we use a separate branch of multi-layer perceptron for each observation block, and that leads us to better solution quality on the same policy proximal optimization algorithm, hyperparameters, and learning steps. So we used Brandermite benchmark, which consists of 10 problems and the same hyperparameters I mentioned on the screen to train our algorithm and then compare final make span at last operation scale. So here we could see an example on the schedule we have from this approach. That's mark 07 problem from this problem set, and we can see that we have like a dense schedule, not much of free time left. So and this approach could give us like visually very good schedules. On the next step, I would like to compare like ablation, the difference on the make span we have from single branch implementation and multi-branch implementation, and the difference is up to 27% on Markov 6 problem. And the single problem we have like worse result is Markov 08, but it's like less than 1%. So in conclusion, we could say that careful work with observation space, usage of different semantics block processed separately could lead us to better results in reinforcement learning and combinatorial optimization, which is proved on none of the 10 benchmarks from BrainGermite. Yeah, and that's all from me. Thank you, and I'm ready to have questions.
Thank you very much, dear. I just want to know, you have used PPO and a multi-branch NLP. Just want to know about the complexity of your architecture. Have you done any analysis? Because in single layer MLP and multi-layer MLP, you just stated that its performance improved. But have you done the architectural complexity or computational complexity analysis of this framework?
I haven't done a computational analysis, but for this part, the layer number is the same because I split it like not on layers but on widths. So I split it those layers into 3 parts and keep like the total width the same. Just split it on the 3 different branches. So probably that would be the same complexity. And the same inference I have that probably it could like prove that.
Thank you.
Thank you for your presentation. Now I'd like to call upon our next presenter, Crystal James Toomey, sir, to present his paper titled A Hybrid Deep Learning Approach for Network Intrusion Detection System and Software-Defined Networking. Sir, can you please start presenting?
Yeah, sure. So, good morning, everyone. So this is what we have done is a deep learning approach for network intrusion detection system and SDN networks. We have done this project with 2 of my members, Anna Eve and Nakirna, and our guide, Professor Linda Sarah Matthew. So the problem we face in modern network is that we generate large volumes of data, and the modern SD networks also face dynamic and high volume traffic. But the traditional intrusion detection fails against zero-day and evolving attacks. That is, it cannot generalize or it cannot detect new and evolving attacks. So what we are trying to do is we are trying to use a deep learning approach to provide an adaptive intrusion detection system. In this work, we are proposing a CNN transformer-based intrusion detection system. So these are some of the papers we referenced before, so that we can identify what are the major research gaps that exist in the current systems we have. So these are the research gaps which we have identified, that is inadequate joint spatial temporal feature learning. Also, there is a high latency for the sequential models like LSTM and bi-LSTM. Also, there is lack of explanation as to why this is happening, why these attacks are happening, and how we can prevent them. Also, most of the IDS models only focus on detection only, not the mitigation part. And the real-time deployment also is not feasible in most of these IDS models because of the high controller overhead. So our key contributions in the work are a hybrid model, which is used as especially for SDN traffic only, a flow-based intrusion detection rather than being packet-based, and we have integrated explainability for the decision transparency, so we can know why this particular prediction has happened. Also, there is a dynamic mitigation for which we use a review control, which is basically a SDN controller, and we are also through these methods we are reducing the control overhead in SDN. So problem statement is to design a real-time explainable intrusion detection and mitigation system for SDN using a hybrid CNN transformer model that accurately detects complex network attacks and dynamically enforces mitigation through the SDN controller. So in the proposed solution part, the first one we have to do is the SD network setup. So in this project, in this work, what we have done is that we are simulating a entire network traffic using some of these tools. The first one we use is a mininet, which is used for network emulation. It creates virtual switches, host, and all the other network traffic parts. Also, then we are using a OpenV switch, which is an OpenFlow enabled switch, which is used to connect the mininet with the Rio controller, which is basically our SDN controller. So Rio controller is the centralized control plane, which is the SDN controller which we are using in this work. We will collect the flow level statics in real time using the Rio controller. So for monitoring the traffic, we are using the Rio controller, and the Rio controller periodically requests the flow statics from the OpenV switch. The OpenFlow messages, which or the functions which we use, are the flow stats request and the flow stats reply. In regular intervals, the Rio controller will request these particular flow statistics from the OpenV switch, and it collects the following parameters during this particular operation. That is the packet count, the byte count, the flow ration, and the TCP flags. So for training our CNN transformer model, we have used a dataset known as the InSDN dataset. It's a dataset which is specifically made for SDN work environments. So we did some pre-processing steps such as feature selection, normalization, missing value handling, and data balancing, so as to avoid bias to a one particular attack or attacks. So this will ensure our training is unbiased as well as robust. Now comes the main part, which is our CNN transformer model. So the CNN module is used to extract the spatial traffic patterns. That is, it is used to detect what is happening in the network flow at the moment. It is used to learn the local features, whereas the transformer module captures the long range dependencies. That is, it is used to detect how this particular network traffic evolves or how it behaves over time. So the transformer uses a self-attenuation mechanism, which enables us to capture these long-range dependencies, since it processes multiple steps or multiple flows at the same time. So basically, as I said, it enables parallel processing and provides higher accuracy. We have also implemented an explaining layer techniques, which is used to interpret the predictions of our model. Basically, we use the SHAP model, uh, since because it uses the green theory, and it also helps in a fair distribution of the prediction values. Like of each, if you are able to understand how each feature contributes to the prediction that we get, the prediction we get. This improves the transparency and also the interpretability of the decisions that is made by our IDA system. Next is attack mitigation mechanism. Upon detecting attack, if a model detects whether the particular flow is an attack, what we are trying to do is that our real controller will install some mitigation rules. These rules are installed in the OpenV switch. Uh, and these actions include like blocking malicious flows, dropping these attack patterns, and tumble resistant traffic. These rules are enforced by the real controller in the OpenV switch. And when these are enforced, if the upcoming traffic from this particular source IPs won't be forwarded towards the destination IPs. Instead, they will be dropped from the network. This is an architecture diagram of our work. So it consists of three main modules. That is the network simulation modules, the data pre-processing, the model training phase, and the model testing phase. So this is a basic workflow of our work. So it starts from the traffic generation. At first we will generate some normal traffic, and this traffic is then forwarded towards the OpenV switch. From OpenV switch, this traffic is periodically collected by the Rio controller, and from under Rio controller we extract the features which are required for our model. And this particular feature vector is forwarded to a model, and the model's output will be the traffic classification, whether it is normal or the type of attack which it has detected. And after it will make the decision based on the attack. If it is a normal traffic, then we will install a forward rule on the OpenV switch. and then traffic will be forward towards the destination, so destination IP. If it is a drop rule, which is mean it will be an attack mitigation strategy. So basically, as I discussed, this is a attack implementation pipeline: the traffic generation, the flow data collection, feature extraction, model inference, and the mitigation rule installation. So this is basically the tools we are used for the implementation of this particular project. For the front end, we have used HTML, CSS, JavaScript, and the back end, we have for the SDN environment, we have used the Mininet, the OpenVSwitch, and the Rio controller. So our results of this particular project are we have attained a accuracy of 98.7% in total. Also, our key observations are like we have very low false positive and false negative rates, and also our ROC curve shows excellent class separability, which means that our model is able to distinguish between the classes in a very good manner. Also, we have a very low detection latency, that is between 1.8 to 2 to 3 seconds. In the previous models which we have researched about, the detection latency used to be 3 to 4 seconds. Also, we have a 73% reduction in packaging messages after mitigation, which means that the number of messages which have dropped has considerably reduced because of the proper detection. These are confusion metrics of our work. As you can see, the true positives and the false positives are very high, whereas the true negatives and the false negatives are very low. So multi-class confusion metrics, here also we're able to get good results for each type of attack. Also, we have compared our particular model with the existing models, like the CNN only work for which we got these particular accuracy values from a previous work. It has only 95.8% accuracy, but whereas our model, the CNN transformer model, has achieved a 98.7%. This is a dashboard of the work we have implemented. As you can see, we in the right side, you can see that in the Mininet we have generated a normal traffic, and it has been detected accurately as a Bayesian traffic that is normal in the rear controller. And also in the next step, we can see that we have generated attack traffic, and the results of the model is basically it has detected as a attack traffic. So in conclusion, we have developed a SDN-based intrusion detection system, which uses a hybrid CNN transformer model. It is successfully classifies Bayesian attack traffics. Also, we have integrated the various tools for the SD network so as to create a programmable network setup. Also, we achieve real-time traffic analysis and accurate ML-based detection. So the future scope of this particular work is implemented in real world, like in real world routers and switches and hosts. Also, we also can integrate more response strategies beyond the drop rules, like rerouting the traffic to other something like a quarantine router or something like that. Also, we can enhance the model with online learning with the adaptive threat detection. Like right now, we are already doing offline learning using our datasets, but if we are in the future scope, we can do the online learning also. Okay, we can also improve the scalability to handle large-scale enterprise networks. That's all. Thank you.
Thank you, Krishna. Krishna, I just want to know, you worked on the detection part, right?
Yes.
But in your proposed solution, you also gave some solution related to the mitigation part. I think in your presentation, I was just confused about your the flowchart and your proposed solution. You are proposing the mitigation part as well, but you are saying that you worked in this study only on detection.
Yeah, basically, at first we are using our CN transform model for the detection part. After the detection, we are also based on the result of the detection, whether it is a normal or attack traffic, we are also trying to mitigate this particular the traffic which comes from this particular source IP.
Trying to mitigate or actually mitigating it? If you are mitigating, what are the mitigation results?
Well, we are actually we try to mitigate for some of the source IP flows. We have successfully mitigated. Like we are installing some new rules in the switch for this for the traffic which comes from the particular source IP. Like if new traffic comes from this particular source IP, we are installing a drop rule, which means that particular flow will not be forwarded to the destination.
Just as if you actually worked on mitigations, you can include some results related to mitigation. If you didn't work on it, you can just eliminate from your proposed solution and your flowchart. It's just a suggestion. Thank you.
Yeah, thank you. Thank you.
Thank you for your presentation. Now I'd like to call upon the next presenter, Mr. João Paulo Souza, to present his paper titled Immersive Virtual Reality for Awareness and Development of Emotional Self-Regulation Skills, the case of the Dear Alfred project. Sir, are you present? Okay, I assume sir is absent, so we are actually done with all the presentations. We can move towards the closing remarks.
Yeah. No one is remaining?
No, everyone is done, sir.
Okay, thank
I'll
you very
start with the
much.
closing remarks now.
Okay. Thank you, everyone. We have now come to the end of the session in virtual
Yes, sir.
session 1B. I would like to sincerely thank you all, our presenters, for their insightful and well-prepared contributions. Today's talks covered a wide spectrum of important and timely topics like AI enhanced security, intelligent system, with advanced networking and learning frameworks like reinforcement learning, so on and so forth. The depth of and diversity of the work presented truly reflect the evolving landscape of ICT research. I would also like to thank the participants and attendees for your active engagement and active participation, which made this session more interactive and valuable. Special appreciation goes to the conference organizers and technical team for ensuring the smooth execution of this virtual session. We hope that the discussions and ideas shared today will inspire further research, collaboration, and innovation among all of you. Thank you once again for being part of this session, and please stay tuned for the next sessions and announcements. Thank you very much.
Thank you so much, sir, for your kind words. I would like to sincerely thank our authors for the excellent presentations and contribution in this session. I hope the session was informative enough for everyone. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version as well in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Lastly, I would also like to thank our session chairs, Mr. Usman Ali and Dr. Bindya Jain, for chairing the session. Here is a token of appreciation to the chair on behalf of Team ICTIS 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable
Thank you very
presence,
much.
respected session chairs. Before finally ending the session, I would like to kindly request you all to switch on your cameras for a quick snapshot of the virtual conference. Can you all please switch on your cameras? Okay. Thank you so much, everyone. Now we'll be ending the session. Stay safe and take care. Thank you.
Thank you. Good afternoon.
Bye bye, everybody.